Welcome to the tutorial Migration from Python 2 to Python 3. A few words about myself. I've been a Python user since 1999, starting with Python version 1.52. I've been using Python ever since on a daily basis. I gave my first Python training in 2006, and I've been doing Python training on a full-time basis since 2010. I work for Python Academy, doing Python training. Let's get started and download the material. Please go to this link and download the material. Once you have downloaded the material, you will find two folders, one with the source code and one with the PDF. Let's have a quick look in the PDF. Once you open the PDF, you will find the table of content, and I would like quickly go through the table of content so you see what we are doing. So I'll give you a short overview over this tutorial, and the first part is actually an overview of the differences between Python 2 and Python 3. There are quite a few of them. I picked the most important ones, and I think it's important to understand what the differences between these two Python versions are. And then we have different parts. The first one would be cleaning up your Python 2.7 code to make it better compatible with Python 3. The next part is an overview of converting strategies. There are different ways to convert from Python 2 to Python 3. And then we go through some of them in more detail. For smaller projects, you might be fine to write your own compatibility layer. You can also start from scratch. And then there are two different ways actually doing it, starting from Python 2, migrating to 3, or you might have a Python 3 project you want also run in Python 2. All of this will be interactive examples, and we will look at some example Python code. Now we would like to set up some development environments. Since we work with Python 2 and Python 3, we need to have both versions installed. If you have this set up on your machine already, then it's okay, then you can skip forward. Otherwise, you can try the same setup I do. I do use Conda. You can also use pip and pipenv in the same way. So I use Conda to create environments, and then I set up these environments, install Python 2.7 and Python 3.8. So these are the two versions I'm going to use here. So the most recent version currently is Python 3.8, and we want to migrate from Python 2.7. Theoretically, you could do something with Python 2.6, but I would strongly recommend to port everything from Python 2.6 to the 2.7 if you still have this very old Python 2.6 code. So I use Conda. Conda allows to create environments which are very similar to virtual envs you can create with pip on venv. Since I like Conda better, I do this one, but if you have other way creating these environments, it's totally fine. Okay, so I create this environment with Conda create minus name tut for tutorial 2.7. So, and I say Python equals 2.7, and then I would like to install some software, and I can already install Jupyter Lab. So I'm gonna use Jupyter notebooks here to do the work, and I use Jupyter Lab. You don't have to do this, but you can follow this. All these things can be done in different environment, interactively in a file, whatever you would like to. But Jupyter Lab is a good teaching tool, and also in the end I can give you all these notebooks, and also in HTML or PDF version if you prefer. Then you don't need to install Jupyter Lab, and you can still read through what I did here. So that takes a while, so I have to check what's out there, and then I need to install the Python version and the required software. Later on, we will install more software, but we do this step by step. We don't need too much. We need only 2 tools, I think, in the whole tutorial. And then I will show you and give you also the links. And of course, you can also install them with pip. It's not required to use Conda for these purposes. Okay, now we installed our first environment. Let's do the same thing with our second environment. So we use Python 3.8 and do the same thing with Python 3.8. And of course, we call this 3.8. So we have second environment. Okay, now we have 2 environments, and I would like to activate them. And you see the command here to activate the environments, and I make 2 new terminals. And I activate 2.7, which gives me now the Py 2.7 tutorial terminal. And I do the same thing for 3.8. Now I have 2 environments, and if I check the Python versions, I do have 3.8 here, and I do have 2.7 here. The next step is starting Jupyter Lab, and I will give you a short introduction to Jupyter Lab. So I type Jupyter like the planet, and space and lab, and I have to specify a port because I have others Jupyter running. You don't necessarily have to specify this port, but you can just make up some number, and then you start Jupyter Lab. It takes a little bit, so then it starts the server in the background, and it will open a new tab in the browser. You see now in the browser is it will open the Jupyter Lab on localhost, and we can work with Jupyter Lab. So this is now Python 2 version. They have a bunch of other things installed you might not see, and they see here on the left hand side, this is the handout and the source from the zip file. We're going to look in the link, and then we have a Python 2 launcher. So this is our notebook in Python 2, and if I double click on this, I get a Python 2 notebook, which is an untitled notebook, which is not a very good name. I make everything a bit bigger, and I can also turn off the left hand side here, and the first thing I do, I rename the notebook and call this Python 2, and then we are on Python 2, and you will see that we are on Python 2 print without parentheses, which is the first thing works, which wouldn't work in Python 2. You can also check the version internally here, and then you see you get the Python version 2.7.15 from March. So very latest Python version here. Good. This is Python 2. Now we do the same thing for Python 3, same procedure, and then I'm going to show you a few basics about the Jupyter Lab. If you know this already, you can again skip ahead to the next section. So I go back to my console, and I go to the Python 3 and type exactly the same command. And I use a different port. And then again, it will start a new tab in my browser, and I get a second notebook which looks exactly the same, and we can work with Python 3. So there's something small error messages, but doesn't matter. And I get another one, and then I call this Python 3. It's important that you rename it, otherwise you might end up in the wrong notebook. And then there's a question, I want this kernel, Python 3, and then usually you will start with something like this, yeah. And I do this and I start a new notebook, and I do rename the notebook to Python 3. So if you're interested in the notebook, you can discover some of these menus up here. You can look at them, which are pretty self-explanatory. They have a lot of options. We don't need all of them. Now you can turn off the sidebar, which gives us a bit more space, and you can make it bigger. And just a few words about this Jupyter Lab, if you don't know how this works. So we have a cell, and the cell is a Python code cell. When I press Shift Enter or click on this arrow up there, you see, then we execute a cell. A cell, you can write a full Python program in a cell. So if you like, you can define a function here, and then this function will be available later. Takes a little bit, and then, oh yeah, so it takes a little bit of react, now it came with return, and then you can use the function here and calculate something. In addition to this one, you can also use Markdown, so you can change the type of the cell. So you can do this via this menu, or also with a keyboard shortcut, which is Escape M for Markdown, and you can turn to Markdown, and then you can write Markdown. Probably you're familiar with Markdown. So Markdown is a lightweight markup language, that's why it's called Markdown, and I can write a header fourth order and a header second order, and I can write a bullet list with a space. You have to put a space, you see, you get syntax highlighting, and I can do something like this. So you get some basic syntax highlighting and formatting, and then you can write text. That's pretty much most features we're going to use here. That's what we're doing. Otherwise, we switch back and forth between these notebooks. You can also start a terminal. So if you like, then you have the terminal with a Python version. That's also possible. And about other things, and there's a lot of help. So if you go to help, you'll find a lot of help about Python and other packages. So yes, you can see here there's a lot of scientific packages because Jupyter Lab is used for scientific purposes, but you can still use it even if you don't do any scientific computing. Jupyter Labs are very nice to test something, to play with something. And that's most what we're going to do here. We want to play with something, and therefore we work with Jupyter Lab. So you should be able to do exactly the same in this notebook here. So you can do this. If you would like to insert a cell, I can press Escape A for insert above, Escape A, and then you have a new cell, and then I say Escape 1 to have a header Markdown cell, and I can just write something here. Yeah, so I can write something up here. And now we have a Python 2 and a Python 3 environment. Now we would like to look at the differences between Python 2 and Python 3. I will go through them step by step and show you all the major differences between these two versions. For this, you should make new notebooks. So I make a new notebook in Python 3 and one in Python 2, so I can switch back and forth between these two versions. So I make a new notebook and rename this difference in 3. And I do the same thing in Python 2, so you have a new notebook with the differences in Python 2. So now we can look at the differences. The first thing that is different is the print function. So print function is the first thing, the simplest one most of you will know. about it, but yet we can start with it and we can see how it works. So print here is a statement, so I have to say 1 plus 1, and I get 2. And if I do the same thing in Python 3, so I go now to my Python 3 and do the print function. If I try the same thing, print 1 plus 1, I do get a syntax error, and it tells me I need to add some parentheses to get print. So I can do the print function, and I say 1 plus 1, which gives me 2. This works. So print is interesting. Now print is a function, and this gives you a little bit more possibilities, because now you see I print 1, 2, 3, and it puts a space, but the print function provides an optional argument which is called sep, and I can change this separator to something else. And now you see, instead of a space, I do get a comma in the space. This does not work in Python 2. So go back to Python 2, to the print function. So you can put a parentheses, but that's not the same. Some people say you can do this, because this parentheses just groups, so Python just kind of remove the parentheses. If you want to try something like this, you get a tuple. So it's unfortunate, because it still works, yeah, but the result is obviously different, because now you create a tuple and then you feed the tuple as a print statement. But now we have one from future imports. So Python has this from future import. This is not necessarily connected with Python 2 and Python 3. This exists earlier. So in Python 2.5, you can say import context managers or something like this. So you can import a feature that comes with the next version of Python in an older version to some degree. And now if I do this print, now I do the same thing. I just copy my line, and I do get my print looking exactly the same. And I can now also use my sep here, and it works. Yeah, now my print function, if you look at this, is now the print function. It might look a bit different in Python 3. So in Python 3, if I type print, exactly the same. So it's exactly the same. Now we have a print function. So there are a bunch of features you can actually from future import. This is probably the easiest thing you can do. So if you still have to do something in Python 2, from future import, whatever makes sense here, and use a newer version, and then you don't have to do anything in Python 3. You can use from future import in Python 3. I copy this line. So there's nothing that prevents you writing this. That doesn't have any effect. It doesn't change anything, because you're in the future already. So from future import doesn't change anything. So it's pretty safe to do it, because it's just like a no op. It doesn't do anything. But this is the first thing. So you have this future import. Next thing, iterators. In Python 3, you will get iterators at many places. For instance, when you zip something, so if I zip these two strings together, it's a zip function, I do get a zip object, which is not too useful. That's why I call it Z. And then if I use next on it, then you will see it provides next, because it's an iterator. If I do the same thing in Python 2, so I go back to my Python 2 version, and I write my same header, and I look at iterators in Python 2, and you can see this one gives you back a list. So this is always eager, that gives you back a list in Python 2. In Python 3, it is an iterator, which is a lazy thing. If you want to achieve the same thing, you have to convert it to a list. So you have to materialize it to actually create this tuple. Otherwise, you get an iterator, which can be very beneficial if you work with bigger structures. Then you might not need to create this intermediate structure. If you might find a fitted to dict, like if you would like to create a dict, then you don't have to create a list before you create a dictionary. You can create a dictionary right away, which might be faster and also might save intermediate memory you don't have to allocate. The same thing goes for other commands, zip or functions. So the zip function, map, same thing. Map gives you an iterator. If you still use map, you can use list comprehensions. The map is not really necessary. Reversed, the built-in reversed function gives you an iterator as well as filter. So there's a bunch of these things here that do give you iterators. Good. So this would be one thing. So you will get iterators in many places, and you have to do this, and you have to be aware of this. So you will see that there will be some programs that actually kind of add lists like this all over the place to convert your zip to a list, which kind of prevents you from saving the memory, but it makes you compatible with Python 2 and Python 3, because now you can index into this list, and you cannot do this with an iterator. The next thing is range. So range here in Python 3 looks a bit different than range in Python 2. So first of all, you can use range with a very big number, because range generates a range object. So I've forgotten the header. So put the header range. Range generates a range object, whereas if I do this in Python 2, range generates a list right away. So it's materialized. So it's very similar to an iterator. So range in Python 3 is not an iterator, but kind of somehow similar in the behavior. So this one creates a list immediately, and that's it. In Python 3, it's more interesting. It generates a range object, and you can do a bunch of things with this range object, because it's also lazy. So I can give it a name, range, and I can now do something with it. I can convert it to a list, and this converts it to a list. And unlike an iterator, I can converting it again and again and again. And if you don't believe me, that's not an iterator. If you try next, then I do get an exception here, because it's not iterator. So it says explicitly it's not iterator, because next doesn't work. But you can convert it again and again and again. And you can do a bunch of more things here. You can make very big ones, because range objects, theoretically, you can do something like this. And you get it. Don't do this in Python 2, because it creates a list of this size, which is not really healthy, because it uses up all your memory, or you get a memory error, hopefully. And otherwise, your computer might get a bit slower. This range object can also be sliced. So you can slice here, and you can see here now I can slice inside range, and I can get parts of the range. So this doesn't work with xrange. So in Python 2, you do have something called xrange, and xrange is very similar, because it doesn't create the list. So if I call this thing x10 for my xrange, then I can convert this one to a list and can do this again. In this regard, this is the same, but you cannot do this fancy slicing thing. So if you try this one, then it doesn't like you and tells you you cannot slice it. So it's a bit different. So xrange was a kind of intermediate in Python 2, and in Python 3, very often people say xrange got renamed to range, which is partially true. So it's very similar, but you see slicing and all this nice advanced feature that doesn't work with xrange, but it works with range. And also the size-wise, if you try to make a very big one, and you say 10 power of 100, then we get an overflow error. Yeah, so it doesn't work with big ints or with longs in Python 2. It only works with normal ints. So in Python 3, the distinction is gone. You will see this in 1 minute. Therefore, you have this difference. Okay, next topic, dictionary. Dictionary, keys, values, and items. So if you do this, yeah, so if I have a dictionary, so I always create a very simple dictionary here. And now I have this dictionary. I can say keys, and keys is a list. So this list is decoupled. So if I say K is keys, then keys looks like this. And if I do change my dictionary, yeah, then my dictionary changes, but my keys, since it's a list which is decoupled, doesn't change, it stays the same. This is different if you go to Python 3. Yeah, if you go to Python 3, this will be different. Okay, I copy this header so we have the same header here, so you can follow along in both versions. Is the same headings. Good. Dictionary keys. So I can also copy my dictionary from this there, though I don't have to retype this one because we want to create exactly the same data structure to make it visible. And now, if you can see this, we have this D, and if I say K equals keys, so the command is the same, then I do get K keys. And now I modify my dictionary exactly the same way as we did before. And now you can see the dictionary has changed and the keys reflect this. The keys reflect this. We do have now key views that are connected to the dictionary, and they don't have their own data. They just get the keys directly from the dictionary. And if the dictionary gets modified, the K here is different also. And the same is true for values and items. They always give you lists in Python 2 and view objects in Python 3. So that's exactly the same thing. I don't need to show this one. There's a new thing since Python 3.6. Dictionaries are guaranteed order. So they do have an order. So we can show this. So if I have a dictionary and I delete the key A, yeah, I delete dictionary key A. I delete A. Now my dictionary doesn't have A. Now I insert A again, and you see now A is at the end. It's not only shown at the end, actually if you iterate over it will come out last. If you do the same thing in Python 2, so we do this the same thing here. So I delete first I write no order. No order. So if I delete A from my dictionary, of course it's gone. That's not different here. So it's gone. But if I put it back, and you look at this again, you see now it's not at the end, it's at the beginning. So it's different. The dictionary implementation has changed in Python 3.6, and since 3.7 it's guaranteed that the insertion order is preserved in Python 3.7 and above. Yeah. So that's a different thing, so you have to be careful. A lot of people assume some kind of order in Python 2, and if you assume this order, it kind of always came out this way, but it was not guaranteed. So you assume something, your assumption is kind of shaky. It's not given, always, not guaranteed. Then you might have a problem, and you have to be very careful because, as you can see here now, if you iterate over the keys, they come out in a different order if you do something like this. Good. One of the most important things, I would say, are comparisons. Comparison. What you can compare. Comparisons. You can compare things, and then you see I try to compare something like this, and it doesn't work, and I do get an error message. If I do the same thing in Python 2, yeah, so I try to compare. I just copy my code from the other notebook, and it works. So this gives you a true, and if I do it the other way around, it gives you a false. That doesn't make any sense. So comparing numbers with strings, it's actually might be considered a bug, and that's something I still remember when I started with Python 1.5. They talked about this already to being a problem on all the books, and this time there was just a handful of books. They had this prominently somewhere and said, okay, that's a problem, you have to be careful. You can compare these things, so that might be a trap. You might compare something that's not supposed to be compared. So you have to be careful, because here you can compare it in Python 3. It gives you much saner response, and it tells you, can you compare it? So the next one would be integers. So in Python 2, you have two integers. You have the integer int, and you do have a type long. You get a long. So if you make an integer very big, then you get a long. Yeah. So this max int. There's a max int here in Python 2. And if I multiply this by 2, I do get a long. You see it as a trailing L. So there's not a big difference between ints and longs. They all get converted automatically, but you get a string representation with the L. You have two data types. In Python 3, you don't have this. It's gone, which makes your life much easier. So if we go here, so you can say integers, and you have type 1, yeah, it's int. And if you now try to put an L, it tells you it's not going to work. It's invalid syntax, and you can have a very, very big number. Yeah, this is a very big number and still an int. So there's only one integer, which makes your life easier. This was kind of a gradual process in Python, that the differences between longs and int became smaller and smaller, and therefore to just get rid of something. The next thing is mathematical division. So if you do this, yeah, you can divide mathematically. So I'm a Python 3 now, and if I say 1 divided by 2, I do get 0.5. Yeah, so when I divide two integers, I do get a float. If I don't want this, I can do something called floor division, and you do get 0. You have to be careful, it's floor division, and therefore it does go down. Yeah, so with this one, if you want to calculate an index, you don't want to have a float result. Therefore, you can do something like this, and it will calculate an integer, cutting off this decimal fraction there, but going down. Here's a bit different in Python 2. So if you have to divide something like this, if I divide 1 by 2, I do get a 0. I do get a 0, but I can force it. I can say 1. This always works. So if I do this, I can force it. If this one works already, you do get an integer. If you want to force it, you can do something like this, if you like. So if you use one integer there, but you still get a 0. You don't get a 0.5. You would need to convert both of them first to... yeah, sorry. My mistake. Of course, you do get the 0.5 as one of them is a float. That would work. So you can do something like this. But again, there's a future import. And if you use a future import here, by the way, this for future imports can only be used on top of the file. In the notebook here, I can do this in the middle of the notebook, which is a bit strange because then it changes state. And if you re-execute the cell before, it will be different. But it's nice to show the effect. So I can say from future import the decision and works and change the behavior. You see? And now we do the same thing, 1 divided by 2. I get 0.5 and 1 here. I do get this. And of course, this also gives you the negative number. So it has exactly the same behavior. So from future import the decision will solve it. So you can import it. And if you do this in Python 2.7 anyway, then you don't have any problems and no surprises when you move to Python 3. Okay, the next one, strings. Strings is a big topic, and there's probably the biggest change, at least in terms of implications you can have when you move your program. When you have a string in Python 2, you do have a byte string. You see, you have it gives you a type string, but this is a type string, a byte string, sorry. And if you want to have Unicode, you have to use the U in front of it to make Unicode string. Yeah, to make it work, make it a Unicode string, so you have to add the U. You can actually add the B to make it a byte string, which is the same. So if you look at this type here, you do have a string type, whereas if you look at this type, you do have a Unicode type. Yeah, so Unicode got introduced in Python later, and then that's therefore, if you want to have literal Unicode, you have to put a U, and you get a Unicode type. If you do the same thing in Python 3, it's different. So I go back to my Python 3 here. So if I type string, yeah, type the type of string, it says string. So let's be careful. It says string, but it's a different string because this is Unicode by default. So if I put a U in front of it, which is possible, though in Python 0.0 the U was gone, and then I think in Python 3.3 U came back because it makes it much easier to at least put the U, and now you get a Unicode string, but it's called string because it's the default type. Whereas if you use the B for byte string, then you do get byte string. Yeah, and there's no Unicode type anymore because now you have this Unicode as a default. There's no other string, just Unicode. So you have to be careful. You have to really, really careful. Then you work here that you do take care of the strings. So literals, you can always put the U and the B in front of it. You can do this in Python 2 and Python 3, and to some degree that solves your problems. You have to be careful because those built-in functions, many built-in functions accept sometimes only strings, not Unicode or something like this. You have to be careful what works, what doesn't work. You might do some encoding work by hand. So it depends what libraries you use and how they think about these strings. Yeah, so these are the biggest difference, and there's can be a lot of work if you use a lot of Unicode in bytes. Can be a lot of work converting your program from 2 to 3. The next one is encoding, source code encoding. So the default source code encoding in Python 3 is UTF-8. So if you don't say anything, you do get UTF-8. You can still, in the beginning of the file, do something like this. You can write coding, yeah, and then you say UTF-8, yeah, something like this, and you would probably something like this. So this is actually the same. So the default is UTF-8, and you do get UTF-8 code, which is recommended. Unless you have a very strong reason to use something else, I would recommend using this one. Here it's different. Here it's ASCII, yeah, ASCII, and you do have to specify UTF-8. So if you put UTF-8 anyway, it doesn't matter. You have to work with it. Another one in this direction is bytes. So bytes, in string chains, bytes also changed. So we have this bytes data type. Bytes, we are still in Python 2 here. So if I say bytes, I do get this as bytes. It looks exactly like a string because bytes are strings. If I do the same thing in Python 3, so again back to Python 3, and I try to do bytes, I do get bytes. As you can see here, it looks very different. You do get bytes representation of bytes, and you have to be careful what you're doing. Good. The next thing is hashability, and actually now we probably could go to source, to the source directory, because I do have some of these libraries files as source. You don't have to you might not have to type everything here. So I'm just not really sure if I have it. Probably I don't have anything here. So I have some of these files here, but not what I want. So the next topic is hashability. So let's look in the hashability. So for this one, you write a small example. Here I have a class X. So I do write, I inherit from object, so I can copy this over to Python 2. So I have this here. So if I have a class that doesn't do anything, and I do have something like this, equal, and I define equal here, and I return true, yeah, and then I try to hash this thing, to hash an instance of these. So if I want to use it in a dictionary, yeah, if I want to hash an instance of this one, I do get an error. I have to also define a hash, special method hash with 2 underscores. And I just make up hash here, so it might be a good idea or not. I just use the ID here as a hash, and now I can do the same thing, and I can try to hash it, and I do get So that's what you have to do here. So you have to actually calculate, have to add a hash if you have this equal one. If I do the same thing in Python 2, if I do the same thing, oops, something went wrong. Hashability. So if I do the same thing here, and I do hash it, it works. So this works, it gives you some value. In Python 3 it doesn't work. So you have to be careful if you want to use your own objects as keys and dictionaries. You might need to change something. You might get a strange hashability error, and you have to actually, when you have an equal there, then you have to also have this hash. So a few other things that are different. Exec. So there's a bunch of things changed here. Exec is a statement. Exec is a statement here in Python 2. So you have to write exec, and you see it comes directly here, and I can define string. Yeah, and now A is defined. So that's something you can do here in Python 2. In Python 3 changed. There's a bunch of these changes. We will see some more of them. So if I have this here, I do the same thing in Python 3, and I try to use exec in the same way. Yeah, I do get an error message, and it tells me already you have to add parentheses because it became a function. It's still built in, yeah, it's a built-in function, but not a keyword anymore. Actually, you can see this now here. It's green because it's a built-in function. In Python 2, whoops, actually it's a keyword. Keywords. Yeah, why it doesn't get fed? So it should get. There's a problem in the notebook. It should be bold. It should be bold, not yeah. Because if I do something like this, this doesn't work. I can do this in Python 3. Certainly not recommended. Certainly not recommended, but it's possible because just a built-in. Just delete this again, and then I can do my exec again. Otherwise, this wouldn't work. Yeah, so not recommended to do this, but possible. So if you do some kind of monkey patching kind of things, a bit dangerous. It would be possible to override exec, where it is not possible in Python 2. So some of these little changes that might trip you over. Then metaclasses. Metaclasses. So I go to Python. How metaclasses are applied. So if I do this in Python 2 with a metaclass, Python 2, and metaclasses. Metaclasses is something you don't need often, and you might not use metaclasses yourself, but you might use libraries that use metaclasses, and you might potentially see some problems here. So let's have a look at the metaclass. The metaclass syntax is different, and I define a metaclass. This is the same. So a metaclass inherits from type, not from object. This makes a metaclass. So a metaclass is to a class, but the class is to an instance. So exactly the same thing, but only one level higher. So and I just overwrite this representation. So when I type the class, I will see something different. So I have my representation, and here I do get the class, another self. So you can name it whatever you like, but it makes a lot of sense to call this class. And I write something. So that's a new metaclass. And now I would like to apply this class, and I'm in Python 2 still. So I still need inherit from object. We come to this. So we have to inherit from object at this place. And then I can look at A, and if you look at A here, I do get this representation. That's how A looks like. Now I'll make a class B. I can copy this, call it B. Yeah, and now I provide the meta class, and to provide the meta class, I have to do something like this. So something like this. And now if I look at B, the equal sign is missing. Yeah, and if I look at B, it looks different because now I overwrite the representation. Now this is a sign that the meta class works. So if you don't understand meta class, it doesn't matter too much. You might not use them yourself, but if you have any library that uses meta classes, then you see the difference here. So now let's move this to our Python 3 code, so I can actually copy the whole thing. Doesn't work the way I wanted it. I thought I can export all these cells. Yeah, okay, so let's do it step by step. So we do it step by step. So we have the meta class. This is the same syntax. So we do it step by step. That's totally fine. So this is the same syntax, so nothing changed. That works. We can still copy this code directly here. So we would need object, but it doesn't work, so it's the same thing. And now if I do this one here with a meta class and I try something like this, there's no effect. There's no effect, as you can see here. There's no effect whatsoever, it looks the same, because you have to do something different. So let's call this C. And I have to say meta class and I put my meta here. And I can get rid of this line. I have to put a pass. And if you see now, you get the meta class. So the syntax changes, and that's a bit tricky because it's really hard to do something. There's a workaround we'll say later on, but it makes it not easier. So you really have to go in and have to change the syntax, and it makes it more difficult to write a single source code, which is something you can look at later. Good. Good. Next one. This is a nice one. This is a nice one. Super. Super. Yeah. So if I'm in Python 2, I have a class parent, which has an object and doesn't do anything, just has a method. So I have a method. I do have a method, and of course I want to inherit the super, otherwise it doesn't make too much sense. And I say self, do something else, return. So this is a parent, and now I have a child which inherits from parent, and I do overwrite this method. So same signature, and now I call super, and when I call super, I always have to provide the current class, and I have to provide self. Theoretically, you can write whatever you like, but the only thing that really makes sense is this. I haven't seen anything else. So, and now I'm do this, and I just say return. So it doesn't do anything useful here, but you have to write the syntax to actually get something done. Yeah. Now it works. You see, you have to write the syntax. you do have to write this syntax. So again, we can copy this one to Python 3. And in Python 3, this works. It still works. It hasn't changed in this regard. So you can still use it. But it makes your life easier. So I have to do this. And I copy over my child. Yeah, and now I make a child instance. And I call my method, and it works. But you don't have to make it so complicated in Python 3. You can just keep super empty, and it fills in exactly this. So that's nice. If you later change the class name, maybe you don't have to change it here also. And now I call this child2 just to show the difference. So if I make now a child2 instance, still works. Okay, if I try this in Python 2, it doesn't work out of the box. So if I try this one, and of course it makes a class, but later on it does give me a problem. Yeah, so I do get this error. You see, super takes at least one argument and so on, which is this strange error. But we will see later on there's a way to actually kind of backport this one to Python 2. There's no from future import here. You cannot say from future import super. It's not there, but we will see there's some libraries that can help you do this. This makes your life much easier, because it's kind of hard to, why you have to put their results the same. So why not make it easier this place? Okay, one more thing that you might not know, the rounding. Rounding is different. So if I round something here, if I round 2.5, I do get a 3. And if I round 3.5, I do get a 4. Yeah. And if I round 4.5, I do get a 5. So it always rounds up. It always rounds up. In Python 3, this changed. And it changed to what's called merchant rounding. So if I round here, if I round here 2.5, you see now it rounds down, and also gives me an integer, by the way. And here round 3.5 rounds up to the next even number. It always rounds to the next even number. So it ends to on a 5, then it rounds to the even number, and therefore this rounding changed a bit. Yeah, so 4.5 rounds to 4. You have to be careful if you do rounding. So first it rounds to the even number, and as you can see here, this one gives you always a float. Here it gives you an integer when it rounds. So the rounding changed a bit. And the step of you might not notice it, yeah, until you have something you don't expect. So you have to be careful. Then when you use round, that you might get a different result. Good. One more thing is scoping of exceptions. So if I have an exception, if I do something stupid like this, I say try 1 divided by 0 except 0 division error as R, I can say pass. Now I can access R later. This works, and I do get the instance. if I do the same thing here, so if I do the same thing in Python 3, you will see a difference. You will see a difference. Yeah, so if I try to access here, it gives me an exception. I can access it only here because it is only alive in this indentation, so inside the exception clause. If you're outside, error is not there anymore. So that's something, so the exception doesn't slip out anymore, and you have to be careful if you want to do something new. Good. These are important differences. There's a few more things I would like to show you. There's some new syntax. So let's look at some new syntax which you don't have in Python 2 and which you can actually not read backward in one way or the other. New syntax. What new syntax do we have here? The first thing is keyword only arguments. You can have keyword only arguments. And let's give you an example. I cannot show it in Python 2 because there's no such thing. So I have this one. I define a function. Oh, the function is missing. Yeah, function. I define a function, func, and this function takes an A. Then there's a star, and then there's a B. So the B is keyword only. So now I can call this function with function A is 1 and B is 2. No problem, this works. I can also call it with A as a position argument. That still works. Yeah, but if I want to call this one with just 2 position arguments, it doesn't allow me because you have a keyword argument. Now this star has a new meaning here. Actually, it says starting from the star, you have to supply keyword arguments. And this B can only supply this keyword argument, if not you get an error. Makes a lot of sense, makes your life easier. You can enforce keyword arguments when you write a function. There's a new keyword in Python 3, and that's called non-local. So I give you an example how this works. So if I have a function outer and I define x equals 1, and I have a function inner, and I say x equals 10, and I call the inner and the outer, and I return x. Yeah, obviously if you call outer now, you get 1. You can change this behavior by, now I have my outer 2 here, and now I use this non-local keyword and I make x a non-local, and I do call my outer 2, and you see now I get back a 10. Now this inner function can modify the x from the outer function. That's a little bit like global. So it looks like global, but it's different because it doesn't actually go to the global scope. It only goes to the next outer scope. So it stays inside the def. So it doesn't go to the global scope. And usually this inner function is not going to move away. Whereas functions in a module might move somewhere else, and then you might lose your global and you might have a problem. So that's what something you can do here. Another nice feature we have here is this unpacking. So you can unpack iterables. So if you have a list, yeah, if I have a list L, it looks like this. Now I can unpack something in different ways. So I could unpack and say start, middle, and you see I use a star again, so it's another use for the star, and I unpack my list, and now the start is the start, the end is the end, and the middle is everything what's left in the middle. And this works for all kinds of sequences, not only lists, of course. So you can have different combinations here. You can also just have start and rest if you like. So if you do the same thing, and I copy this, and you just call this rest, and then you could collect all the rest right there. Yeah, so start is still start, and the rest contains the rest. So that's tuple, or general iterable unpacking, not only lists or tuples, many others, and you can have any kind of combinations. Good. Another one, true, false. True and false made it to actually none. True and false are now Python keywords and not only built-ins. Yeah, so you can see this easily if I type true here or false, then it's a keyword. And if I try something, yeah, try something stupid like this, it gives me an error message. Now I can go back to here, Python 2, and here I can actually say true 0, and it works now true 0. This is certainly not recommended, yeah, and therefore they changed it. So you can still do this. Don't do it. Yeah, don't do it. You break the whole program, but it's possible to do it, and you can even true is a built-in. You can even overwrite the built-in true. So if you look in the built-in true is still true, and if we now say is true equal to true, then it gives you false because now it's 0. So that doesn't make a lot of sense. Yeah. Now they have two different truths. Yeah, don't do it. In Python 3, you cannot do this anymore. It's gone. Another one are list comprehensions. This is something which makes Python 3 a bit more consistent. So if I have a list comprehension, so if I create a new list, I say x for x in range 10, yeah, so make a new list. And you write x, it also works. So if for x and x in range 10, then the x leaks in the last x is right here. If I do this here, and I try to access x, x is not defined, unless I would have defined it before, but it wouldn't be defined then. So x is not defined, so x doesn't leak out anymore of this scope of the list comprehension. So this x is confined to the list comprehension scope, which makes things much more useful because you don't create an x by accident, just using list comprehension. So another thing in Python 3 is so I have to built-ins. The built-in module has changed. So there are some strange names to built-ins instead of built-in. So, and I make this here a 2, header 2, and here I have to make it a literal string. Okay, built-ins. So here it's called built-ins. Yeah, it's actually the built-in is still there, but the module has changed. Here it's called built-ins, whereas in Python 2 it's called built-in, the built-ins module. So you have to be careful. There might be some small changes. There's a few more things you have in Python 3.7. You have async. You do have async and you have async await. We don't do any asynchronous programming here, so we don't go into any more detail how this works. But these are two new keywords that are here in Python 3.7, so you have to be careful. There's also the walrus operator in Python 3.8, so it's a very new one. This is a new syntax we don't have. So we do have this walrus operator, this one, which allows you assignment in an expression. So we don't need to do this here, but it's a new one. So we cannot use it immediately anyway. Probably not even yet, because 3.8 is not that so long out there. Therefore, we have to be careful. In addition, there's a lot of changes in the standard library. So some of the standard library names are renamed. So there are some standard lab renaming. Some of these libraries, like some older ones like GoForLib is gone, and the HTTP library has sub-libraries and so on. Standard lib has changed, and there's a bunch of these namings. Most of the names now are lowercase, but not all of them. Some still have some uppercase letters, and they have kind of a little bit inconsistent there. But if you do some import, you might need to try import in Python 2 and Python 3, because the names changed a little bit and they moved around a little bit. So you don't have to go into detail here. That's a lot of things you can do. Okay, let's do a short exercise. So if you go in this directory source, you will find a file in exercises. You will find the file manual, and you can look at these files. So just open an editor, or I can open it here with load. Yeah, and you see this is a file. This is a Python file, and please apply some of the changes manually to make it work in Python 3. Make it work in Python 3, and then look at the list. You will find a few things that might give you a problem in Python 3. Try to run it in Python 3, and with run, gradually make it work in Python 3. Okay, a few minutes spent on this, and then we look at the solutions. Okay, I hope you are finished with the exercise. So let's have a look at the solution. So this is a class. So first you have to read through a little bit to understand how it is. You have the worker and a controller, and the worker is pretty easy. It has a name and a value, and you can compare two workers, and you compare by the value, but you can only compare them if there are instances of worker here, in this case. And there's a representation that puts together the name and the value. Yeah, so I'm still using this old % formatting here, which still works, so that's okay. Then you have a controller that also has a name, that has a dictionary with workers, and then you can add workers, and then you can freeze the state that gives you the current keys of the workers. And we have a function that makes two instances, worker 1 and worker 2, and then it shows if these are equal. and then you have a controller, you add a worker, then you freeze the state, you add another worker, and then you show the state. So now the easiest thing, just let it run, and you will see some exceptions. So the first thing, if you try let it run, you get a missing parentheses around print, so you have to fix the print, you put parentheses around print. That's easy to warm up. Once you have this fixed, you let it run, you get another exception, and here it gives you this unhashable type. So as you can see here, I'm using this worker as a key in the dictionary, and there's an equal here, but there's no hash, so I have to provide this hash special function, and that's what I implement here. Just return my own ID, which should be safe, and then I can use it in the dictionary. And then there's another logical error. You see, I freeze the state here after adding the second worker, and then I add another worker, and if I look at it, I see, okay, now I have two workers, but if the state is frozen, then here I would like to get the current workers, then it should be only worker A. But since we use it in Python 3, the keys are lazy and they just point to the dictionary, that they don't really freeze the state, so you need to convert the keys into a list before freezing. Yeah, and that's what we do here. So we convert it to a list, and then when you freeze it, you will see only worker A is there. So this was easy to warm up, just a few things. You can see some of the things are very obvious. You get an exception, that's very easy to fix. Some of things still work, but the result is different, and that's way harder. So you have to be really careful that this keys thing with the dictionary here can be a problem. If you get an exception, then you need to fix it, otherwise your program doesn't run. But if it runs through with this data coming out, you need to really check them. Okay, that's an exercise. Now we know the most important differences between Python 2 and Python 3. The next session will be cleaning up your Python 2 code to make it work with Python 3. So I make new notebooks, again in Python 2, about cleaning up. So I make a new file, notebook, and call this cleanup. And then I show you the most important things you need to do to make your existing Python 2 code work better. So it's still 100% Python 2 code, but it works better on Python 3. So I rename it, and I call it cleanup 2. And I do the same thing. I do the same thing in Python 3. So I make a new file, notebook, and I call this cleanup 3. Okay, the first thing I would like to point out is no classic classes. So Python 2 has something called classic classes. They're very old. And they should not be used. So if you define a class classic, that would be a classic class in Python 2, and you don't do anything. And this would be what's called a new style class. Where you inherit from object. So inheriting from object makes a new style class. And now if you look at the type of these classes, it's a class object where the type of this new style class, it's a type. So don't use old style classes, because when you have them, a few things won't work. Descriptors won't work, property don't work, metaclasses won't work, and other things. In Python 3, there's no such thing as classic classes. There's only a class. And it doesn't matter if you inherit from object or not. So this one, let's call it class A. And this would be class B, which inherits from object actually. So I inherit from object, and you will see there's no difference. So if you look at the type of both classes, they are both class B, and they are both type. Yeah, there's no difference. So take-home messages don't use classic classes anymore. Use new style classes. They've been around for literally decades. Okay, another thing, no backticks. So Python 2 has something like called backticks. So with backticks, you could do something like this. If I define A here, I could get the value of A with backticks. Yeah, so if I do this, you will see backticks, and they don't exist anymore in Python 3. Back to Python 3. No backticks, literally. So yeah, one means don't use backticks here. It means there are no backticks. So if I try to do the same thing and try to use backticks, it doesn't work. So that's a feature that doesn't exist anymore. So don't use it. Okay, the next, don't use old operators. And one of the old operators you should not use is a not equal operator, which looks like this. So here you can do something like this. This works. But better use this. This exists. And this also works in Python 3. There's no such thing anymore. So you cannot use it. Therefore, better remove it in Python. So if I try to do something this, I get an error message, but of course this one works. Simple thing, search your code, change it, makes your code more modern, also works better. The next one is exceptions. So in Python 2, you can write an exception like this, which looks useful, but maybe it's not. You say try 1 divided by 0, and then I have an except. And I do accept, of course, the 0 division error, but I also accept something else, like a variable. At least I tend to. So now if I print this class here, and I print this class here, then you will see the value arrow looks very strange. And in fact, the value arrow is not what you think. So I overrode value arrow here, which is not a good idea, because actually what you actually wanted is this. What you actually wanted is this. You wanted to have this in arrow. This is an old syntax where you have an instance of this arrow. Yeah, you see now, and if I print L instead of this value, you see that's what you wanted. And this is an old syntax you can do. Don't do this. Use this syntax. Use the as syntax, which gives you exactly the same and which is more modern. So now I killed my value arrow, which is not good if you don't have any exception here anymore. Or at least can be very misleading if I want to use value arrow. Therefore, I just delete value arrow and then value error is back, and now we get a built-in value error because I deleted my global value error here. So if I go to exceptions, if I copy exactly this one to Python 3, you see it's different. Yeah, it's invalid syntax. It's invalid syntax. You have to use the as, and when you use the as, then it works as expected. So, and you can do this in Python 2 already, so do it. Next one is no leading zero numbers. So no leading zero numbers. In Python 2, you can do something like this. You can use leading zero. You see, it's turned red already because my syntax highlighting shows something wrong. It still works. If I try to do the same thing in Python 3, so again, jumping back to Python 3, and I do the same thing in Python 3, then I try to write this. It doesn't work. I get syntax errors. The solution would be using 0, lowercase o, 7. This would be an octal 7. So if you want to write octal numbers for some reason, then use this syntax, and this syntax already works here. So you don't lose anything to use it. It looks much better, and it works in Python 3. The next one is open. The next one is open text files in text mode. Open text files in text mode. So I do have a file which is called umlaut. So there's a file called umlaut. And now I try to open. So I do it nicely with. Yeah, so you can use with open. I try to open this file, yeah, the umlaut, and I try to read and print its content. So just print the whole file content. So I read the whole thing. You see, and I try this, and it doesn't look nice. It doesn't look nice. If you do this in the command line, you get an error message. So it doesn't look nice because I didn't specify the encoding. You just read it as it is, and it's not UTF-8 encoded as my notebook assumes that gets a UTF-8 encoded string. So I need to specify the encoding. So if I try to do this, I can open this here and say encoding. Is Latin 1. I know that's Latin 1 because I made Latin 1. And if I do this, I get an error message and tells me, whoop, there's no such thing as encoding for my opening. So I cannot specify encoding. I can specify the encoding by reading, but you can say import IO. So there's an IO module. And now I swap out the built-in IO with the built-in open, sorry, with the open from the IO module, and it doesn't work. So I can print my name here with my umlaut, and you see it works. And this is now very, very similar to doing the same thing in Python 3. So if I copy this, I can actually do both of them in Python 3. So I copy this in here, and I write, and I'm too lazy to type the whole thing, as I copy the header also. So you know it's the same topic. And I can actually import IO here. And it works, yeah, works the same thing, but I can also just use this one and drop the IO because the built-in IO does built-in open does exactly the same. Yeah, so this works here in Python 3, and you can still can use IO open. Of course, in Python 2, you could just say from IO import open and override the built-in open, but you have to be careful. Then you have a new open. You have to make it consistent. So that's a good thing to do it right away. So next topic, use next. So use the built-in function next instead of the method next. So if I have an iterator, yeah, in Python 2 I can say iterator.next, and it works, but I can also use the built-in function next, and then it also works. So in Python 3 there's no such thing as a next method on an iterator, therefore it wouldn't work. So if I try to do the same thing here, so I have to make it Markdown. Try the same thing here in Python 3. So I make my iterator, yeah, and I try to say next, then it doesn't like me and tells me no, there's no such thing. And then if I say next, it works. It works here, and it works in both versions. Okay, these are the most important changes. Other changes that you have to be aware of, I would like to make you aware. So reduce still exists. Reduce here, so you can use a built-in reduce. This doesn't exist in Python 3. No? Go back to Python 3, just to make it consistent now. Other changes, there's no such thing as reduce. If I try to reduce, it tells me no, there's no such thing. I can import from functools, import reduce, and then you have it, and now you can use reduce. So I'll move to functools. Another thing is you could use apply. If I have a function, then you can use apply. For instance, I have a function that sums the arguments. Yeah. And now I have my args, and I can put my args in a list or in a tuple, whatever you like. And now I could say apply, and I put my function, my sum, and instead of spelling out my arguments, I just give it as a tuple, and then it would work, and it adds all these numbers. This doesn't exist anymore in Python 3, but you can use the star syntax. So I can say my sum, and I use this star here, and I give my args, and this works. So this works in Python 3 also. So just to show, so in Python 3 there's no such thing as apply if you try, but you can use the star syntax, which is the preferred way of doing it. And I have to specify the args first. Specify the args first. And now it works. Yeah, so that's the way to do it. Another thing is the raw input. Raw input, you do have raw input in Python 2. It's something, so I can create a prompt which will be translated to a window here, and you see whatever I type into raw input, so I type 1 + 1, which will be returned back as the string. 1 plus 1. As opposed to input, yeah. So if I do input, it looks the same superficially, but if I say 1 plus 1, it will evaluate my expression and I get back 2. That's not nice. So if you use input, then you potentially execute code somebody typed in your program. Usually you don't want to do this. Therefore, they changed it in Python 3 input. If I ask for input and I type 1 plus 1, then it gives me the string. And if I want to have the same effect, I have to write a val around it explicitly and do something like this. And there's no raw input anymore. It's gone. So you need to change your program. Of course, you can rename these things. Yeah, you can rename raw input to input, and then it will do this. Another thing is you have a reload module. It's not too much recommended to use it, but you can reload things at runtime. This one doesn't exist in Python 2. This one doesn't exist in Python 3. If I try reload here, reload, then it doesn't exist, but you can say from import lib, import reload, and there you have it. Now it's the same reload, it's just moved. There's a bunch of these things they changed. There are some ways to work around it, but you have to be aware of it. Next is an exercise. So please go to the directory for the exercises, which will be exercises, and there you will find a file called old style. It looks like this, and make this file more modern. So everything stays Python 3, but please make this file more modern. Please make this file more modern and keep it in. Everything stays Python 2. Everything stays Python 2, of course, and make it modern Python 2.7. Get rid of all the old things, which will be much easier than to convert to eventually Python 3. Okay, let's have a look at some steps we can do here, some solutions. So we have our exercise. You can look through the code. It's not very interesting code, but I put a few things in here. And you see what I did. I can go through and I can look at some of these things, what you can do. So you can say from future import print function, and when you do this you get an exception, and then you have to change all the prints with parentheses, and then it works with print. That's the first thing. Another thing you can do, you can replace this old unequal sign with a new unequal sign. So you just go there and replace it here at this position. That's something you can do. The next thing you can do to make it more modern, use from future import division. So you don't need to divide by the float. You see up here I convert to a float and divide by 3. You can do away with the float if you have them from future import. And then you have this this possibility just to do this division without it. Also the next one, do this division here, so you can have this floor. Then you don't have to rely on it. It works and it's more explicit to do this. So that's nicer to do it. Doesn't change the thing yet, but makes it more future-proof. You can use list range. You see here, because I rely that range gives me back a list because I index it in there. So if you put list around, it doesn't change a thing, but it makes it future-proof for later on. The next one, you can convert the octal number from this to this. It works and makes it future-proof for Python 3. So there's a different way of writing this. You can also this exception. You see the exception up here. The exception up here uses this old comma version, which is kind of problematic because it won't work in Python 3. So use a as to make it more explicit. Use a modern version with the as here, and then it would work in Python 3. Then you can also use IOpen, and then you have to use a Unicode string, and you might even consider encoding if you like. But if you do this here, you import this as open and overwrite it, and then you need to specify the Unicode string here at this position, because otherwise it doesn't work. We have the Unicode, so we put a U here, which also would work in Python 3. So these are a few things you can do here. And there's one more, you see, the next. So you use the next here, and you can now also improve the next. So let's do another step and do the next. Yeah, so you can use next instead of using this one. So here you can replace the dot next with the next. So that's why you can go slowly through. Whenever you see something like this, you can replace it, make it more modern. When everything, even if you have to still work in Python 2, you use the new way of doing things. Not get rid of the next. Yeah, so this would work now because now it's doing the next. There's a bunch of things you can do, and you can slowly go through the code and see if there's anything else you can do here. See here, yeah, so that's okay. And you have the decision. We have this one. We have our next. Here you can use the with syntax. So this would be another one. Here, this is old. You might inherit old code like this, but you could also use with open to open and close, which is always a good thing. So that's what I'm going to do here now. So I say with open. Yeah, to use the with open thing, and I just copy the code and get another time. So just you can see step by step how this goes, and you just do here a with open, and then we even save this one line, and it's gone. So step by step you can improve the code, make it more modern, and this makes it easier later on to move to Python 3. Good. Nothing changed. Works in Python 2. Make those things modern. This is something, if you have a little bit spare time, go through and do it. Makes your life easier later on, and also makes the Python code better without changing anything in Python 2, and then you're ready to go into Python 3. Our next topic are converting strategies. So we'll have different strategies for conversion. So you can do everything on your own. So you can roll your own kind of small library. That might be useful for learning something, for sure. If you have only a small project, that might be okay. You don't have any dependencies, and you have full control of the process. Of course, you have also full responsibility, and you can learn quite a bit. If it gets bigger, it can be a lot of work, and of course, you might miss quite a few things that you don't know, and it's very easy to make mistakes. The other strategy would be using external libraries. The two most prominent ones are 6 and Future. So 6 has been around for quite a while, and it's backward compatible with Python 2.5. The thing is, you have to modify your code, and you have to put special function calls in there that make your Python 2 code compatible with Python 3. So you have the single source thing, but you have to modify the code. Another tool is Future. You'll find it at Python Future org. And we're actually going to look at this a little bit more. And this is an interesting tool that allows you pretty much programming Python 3 style in Python 2. So you can have Python 3 code more or less in Python 2 running. Of course, you cannot use all the latest features, but a lot of things can be done, and that is usually much better. And using this tool, there are different options. You can start from scratch. So you develop a new library, and you want to work with Python 2 and Python 3 at the same time. That can be something. Or you have a Python 2 library and want to move to Python 3, which is probably the most common case. Or you have a Python 3 library that you would like to backport to make it work with your old Python 2 code if you need it. All those three things can be done, and we look at some examples. So the first thing is writing your own compatibility layer. Small projects avoid dependencies, and these are the things what you can do, and we will use some of these things. So you get rid of all these old things we just did it. Make your Python 2 more modern. Use all the future imports. Then you should have tests in place. You can redefine built-ins such as range. You can install backports. There are backport libraries. You look at some of them. And then you can manually fix strings and bytes and use modern input-output, for instance. So a lot of things you can do. And this is what we just did, use all the modern tools. Okay, the next thing I would like to show you is something about this for absolute imports. And therefore, we make a new notebook. We are on Python 2 here. And I make a new notebook. And we call it strategies. So there's a bunch of things I would like to show you in the strategies with a notebook. Strategies. So the first thing I would like to show you is absolute imports. That's an interesting topic. For this one, I made a small example library. So if you go to source, you will find a package. So I'm looking at the package. So that's just layout. So this is a very, very simple package, my package in it. And you see we have several files, and there one is called used OS, which is not a really fortunate name, but it's in the package, so it should be a different OS. And now let's have a look how this works. First, we open some of these files and see how they look like. So I go inside my package and I load these files, and you see how these files look like. Load. In the beginning, I load this file OS. That looks like this. Yeah, this just has the function inside, so it's not very interesting. It's just a function to have a file that's doing something I want to use. And then I have this file use. So this uses OS, it imports OS, and from this library it imports OS as tries to import OS as my OS. And then it prints out what OS is and what my OS is. And I have a third library which is use absolute. So, and we look at this one. Yeah, use OS absolute, and see here I import from future import absolute. Okay, let's go to the terminal and do this from the terminal because we want to do some imports, so it's easier. You don't want to import things again and again and again. So we probably do this from a terminal. Actually, we can do this. If you only import once, you don't actually have to go to terminal. You can do this from here only if you want to import several times. So I go up one directory again. I go up one directory, and now I say from my package import use OS. And you see when I do this, I get this use OS, and then I can say use OS dot use OS. And when I do this, then you see OS and my OS is the same package, because when I import it, my OS package takes precedence over the built-in standard library OS package. But if I do the same thing and I import this absolute import, and I do the same thing, and call this function from this one. Now you see my OS is still this my package OS, but OS is the built-in, Python 2.7, built-in standard library OS. So you should use this from future import absolute import. This makes your code nicer, and then those absolute imports work, and it works the same in Python 3. There's no difference. There's always absolute import on. There's no such old imports. So absolute imports is it's a good thing to do, and when you do it yourself, then you should do this for sure. You have to be careful. Unicode literals, you can do something like this. You can say from future import Unicode literals, and this makes, if I do this here, that should be fine. Yeah. And now all the literals are actually, so just I type some text, yeah, and now the text is a Unicode, not string anymore. Yeah, normally it would be str in Python 2, but now it's Unicode, and everything you type becomes Unicode without U. And it can cause problems if you handle things to some libraries that expect strings and not Unicode, then you might get an error message. Yeah, so you have to be careful. And if you want to have your strings, you have to put a B in front of it, and then it should work, because it's not a literal anymore. But why do you want to put a B, but just put a U if you want Unicode one? So this is something you have to be careful. Maybe not a good idea to do this, if you might have problems. Then you should version testing. You should do some version testing. Yeah, so if you test for the version, you can get version or can get version info, so you use version info. Yeah, and then you have major, and you should check major less than 3. Yeah, that's something you want to check. So don't fix it to 2. So say less than 3 and more than 3, greater than 3. Yeah, then this would also work for Python 4 later on, just in case. Yeah, Python 4 will come sooner or later, and then you don't have to do changes again if you still do version checks. I don't know how long it takes to have this inside, but it's a recommended way doing it. Good. You can also override built-ins. You have to be careful how to do it, but it's possible. So I do have a small script that lets you do this. So to override built-ins. So if you look here, override built-ins, load override built-ins. And there's two ways of doing it. You can do it explicitly or implicitly. Let's do it explicitly first. Yeah, explicitly first. So you can do something like this. I import a bunch of things like from Iterators. I import Iterators, IO, and sys, and then I go and check if the major version is less than 3. I replace the namespace here. You see, and I replace filter with Iterators filter, input with raw input, map with IMAP, and so on, range with xrange, and a bunch of these things. Or you can, and then you can use it. What the name is. So now I have this new explicit. So you import your script. The only thing you need to do, you import your script. So you do the future imports. You import your script, and then you say override built-ins, and you hand in the global namespace, and this will change the global namespace. And when you do this, when you execute it, you will see now the zip is Iterators zip, the range is xrange, and the open is iopen, and so on. That's something you can do. That would be, you have to call this here and hand in the global namespace for the module. You can also do it implicitly. So override it implicit. So, and now I take advantage of the fact of the star import effect. So I define this all, which is a list, and I fill this list only if I'm less, my version is less than Python 3, and I just define all these things, and I import these things, and then I export all these things I would like to export. I have here in my namespace, and then it's easy to use it. You just have to import it, and now you have to do a star import. You have to use star import, because star import will import everything that's in all, and then it will replace stuff here. So it's pretty hefty. So you're changing quite a bit of built-ins. Actually, you override them in your global namespace here, and if you have to be comfortable with this, but just at least you can learn something here. In addition, there's a bunch of standard library backports. So the last thing I would like to show you is backports. So there's a bunch of backports. For instance, there's a functools backports where you can have LRU cache, for instance. So in Python 3, we do have LRU cache. I don't have it here. So in Python 3, I make a new notebook, not to publish this notebook here. And I can say from functools import LRU cache, and I do get LRU cache. In Python 2, this does not work. So if I try to do this, it does not work. But you can actually, it does not work. But you can actually install backports, and when you do this, then it will work. So take the tool, pip or something else, and install the backports package, and then you will get the backports functools cache package to work with. So there's a bunch of these backports. You can search Python pack index for them, and you will find backports for a bunch of these new libraries if you want to use them. Good. Next is exercise. So this is an exercise. If you go to the PDF, you will find the exercise. So the exercise is to convert the Python files manual and old style, both of them, from Python 2 to Python 3, and using this compatibility layer. So I gave you this layer, and you can use this layer and convert them manually from Python 2 to Python 3. Okay, let's look at the exercises. So I prepared some of these solutions. It's pretty simple. First, manual, explicit. So if you do it explicitly, then you need to import this override explicit, overwrite built-ins. You have to do the future import because I cannot put it there. You have to put it in the module, and then you set it. Yeah. And there's one more thing. If you run it, you will see you have to fix a parentheses, and once you do it, then you get a program that is compatible and it will work, and you can run it in Python 2 and you can run it in Python 3, and it should work with both of these ones. No problem here. You can work with them, no problem. Should work in both versions without problems. Good. So this would be easy, yeah. So but you have to do it in every file, and of course the old looks the same. So if you do the same thing, old style, load old style explicit, then you see I have to do exactly the same. But also in addition, since I use this open from IO, I have to make the string Unicode. So in addition, I have to here makes the string Unicode, otherwise it doesn't work. The rest is the same, just copy this stuff on the top of the file, exactly the same, set the globals, and there you go. Implicit, very similar, not very difficult, so it's just pretty, and you'll work here, manual, implicit, and if you look at this, copy it on top, fix a print, and now it's a bit less, you just have to do the import here, and then you can do this. Yeah, you don't need IO. Let's copy from the other one. So then, and then you should be able to run it. And then once here, you get it. You have the same output. Good. Okay, and old implicit is also old styled implicit, same thing. So you have to copy this on top, do it the same steps, fix the print, and make the string Unicode. And once you have done this, then it runs as before, and you have your output, and it works. Yeah. So if you run your own, you can do something like this. I don't really recommend it. It's more like an exercise to see what's possible. We should use a library, and that's what we're going to do next. Next, we want to start from scratch. So I make a new file, a new notebook, and rename it scratch. So this is something you want to develop a new library and you want to make it work with Python 2 and Python 3 for some reason, because you still have to hold Python 2 projects you want to support with this library. Then you can do this. I wouldn't recommend it too much, but you can do it here. And I just show you what you need to do there. So let's go to the PDF and quickly go through, so we don't have to do much here. Actually, this would be fine. So start from scratch. If you develop a new library, yeah, then you might need this. You can use Future. We will look at Future in a minute. And then you just need to add this code in the beginning. You need to install Future. And once you install Future, you add this code in the beginning, and then that's pretty much it. And then you can write Python 3 code, and you don't use any new Python 3 syntax. That's something you can do. So, and you should create 2 environments. We did this already, and now we need to install Future. So I'll show you how to install Future, and of course we install it in both Python 2 and Python 3, so we can make it work here. So I go to a terminal in Python 2 and I install Future. So Conda install Future, and this installs the Future. And in the meanwhile, I can do this same thing in Python 3 and also go to the terminal and I install and make a new terminal. Maybe this just is not so crowded. Yeah. Make a new terminal. Yeah, and install Future. Takes a bit, and then install Future. Of course, you can also install this with pip. Won't be a problem. Should be the same thing. It takes a bit, and once you install it, you can this Future library. Yeah. Okay. Now we have installed Future, and then you can actually use Future and apply it. And the easiest way here is you just only have to import this one, and then you keep programming, and then you should be able to develop a library that's Python 2 and Python 3 compatible if you take care of a few things. We don't want to focus on this one. We want to focus actually starting from Python 2 and migrating to Python 3. That's what the title of the tutorial is. And therefore, I make a new notebook, and we start with this new notebook. And then we're starting from 3. From 2. So starting from 2. So and I have a few examples. I have a few examples of this source code, and then we have very easy one, and we would like to convert this this one to 2. So I load this file. I load this file to sample. Yeah. So it's a very easy file. So we only do it with a very easy example. So that's not a real world. It's an artificial small example, but we learn how to use it. We learn how to use it. So you have a file that uses string IO, makes a string IO object, uses next here, and prints out done. That's all. What's doing. So that's a Python 2 file. Actually, it's not going to work. I'm in Python 3, I guess, here. So that's not really good. Therefore, I have to go here and make a new the new notebook here and do the same thing here to show you that it works. So I can rename it in the same directory. Good. So I go to the source and I load this file. I go to the source and load this file. It didn't load. Now it loads. And I can execute here because it's Python 2. It runs and you see it prints. Done. Now I would like to convert it, and I convert it in the console. So I go to the console. I just add here. It doesn't really matter which one. So I go to the console and I check where. I go to the same directory. Yeah. Source 3. And now I would like to use Pasteurize to translate this file from Python to the Python string. So Pasteurize, if you type Pasteurize, you get the help, but it supplies. You see that it has a lot of options. This is a program that comes with Future and has a lot of options. And I use Pasteurize now with a bunch of options to convert. So I use the option list fixes, of course I want to see something. I use this one, list fixes, I will see the fixes. I want to specify a new output directory because I don't want to overwrite my file, I want to reuse it. You can use no backups, otherwise it makes the file.bak, generates a backup file. This would be other strategy. If you move it to a different directory, that should be fine, so you don't have to do this. And also I say write the modified file back. So if I do all these, I say modified. So I use L, N, W, no, these ones, and I specify an output. And now I would like to move it into directory stage 1. Stage 1, so stage 1. In this directory, they're ready, and I want to move my file Python. So, and if I do this, it tells me what it's doing. Yeah, so I use the list option, which gives me a long output here, and you see now it tells me what it did. So it lists all. Oh, I know. So no, it's not the L. Sorry, you don't want to list it. It's a 1. You want to have stage 1 changes. Stage 1 changes, not the list changes. So stage 1 because I'm different stages. Now I have a stage 1 change, and you see it's going here. So let's look at this, the 1 and the 2. Yeah, so stage 2, it will be stage 1 modernized Python only. Yeah, no compatibility with Python 3. This would be make still Python 2, valid Python 2, but you get rid of all the old features. And then you can have stage 2, and then stage 2 actually gives you new Python 3 compatible code. And you can say also both stages and do both. So we did stage 1 first. So I run stage 1. And you see it tells you what it did. So it shows you a diff, and if you look in the file, you see the diff. So it changed the dot next to the next. So one of these things we did manually. So it's good to do it manually. Look, first, you know what it's doing. We did manually. So it moved the method.next to the built-in function next. The rest stayed the same. Now it also added the print function here, and it said from future import print function. So if you look at the file, yeah, there we see now it looks like this, and this is added here. So I had a comment in there, so the comment should be in top, but it doesn't know because the from future import has to be the very top thing anyway, so you put it on top, and then the rest is changed. So this is something you can do, and this might be helpful. If you do this, it should still run in Python 2.7, and then you can convert your code step by step to Python 2.7 with this tool, and you don't have to do it by hand. Good. Now you did step 1, stage 1. Now we can do the same thing for stage 2. So we use again Pasteurize. Stage 2. The same options. So we don't want to have backups, we don't want to write, because we specify an output directory, which is stage 2. Yeah, and we take the one from stage 1. And we convert it to stage 2. And it's doing it and tells us what it did. You see, it does now a few more things. It removes string IO and imports the future standard library and makes a new standard library. So standard library renames. It imports the built-in next, because the next is different, has some small changes. So we actually haven't talked about it. There are some changes to next also. And it imports IO, because it uses now string IO instead of IO. String IO, the name of the module is different. Yeah, it's not capitalized string IO, but IO, and it's there. And now it works. And this now, if you run this code, it should work with Python 2 and Python 3 alike. So we can try this. So if I go here, and I go to converted stage 2, and actually I try to run, I can run it, I can load it, just see when we load it. Should work when you load this thing. Then yeah, so that you say cool. So if it's now loaded, and if I run this, it should now work in Python 3, and it does. And if I do the same thing in Python 2, it still runs in Python 2. Yeah, and everything is now pretty much the same as in Python 3. Yeah, no manual steps involved, and runs. And for most cases, this works pretty well. And doing it with 2 stages, it's totally fine. If you don't want to do 2 stages, you can do it in 1 stage and do the whole thing in 1 step. And that is a conversion you can do. And it is good to go this manual steps first and have a look what's out there, because Future is doing it for you. But it's really, really helpful to understand what it's doing. So if you use L, Pasteurize -L, then it gives you all the fixes. You see, it does many fixes. You see, even there's a fix for metaclasses. They have a fix for pretty much anything. And you can read through. There's way more than we covered here. There's way more small corner cases, details here. And all these fixes, you can read through what they're doing. And it kind of helps you to avoid a lot of manual labor. Good. Let's do a conversion with both stages. So I use Pasteurize. I have my 0 now, means both stages. No backup, right? Converted both stages. And I use my Py2sample, and then it is doing both steps at once. Yeah, and now you see it has all these steps in one go, and it applies, and it tells you what it did. So this is a strategy. This is a strategy. Apply these changes and it works. Okay, what we did so far, we created the file in a new directory, and we had specified the output directory. You can also work with a backup. So let's go back. If you have this file, yeah, doesn't want me. So if I have this file, I'm in the wrong directory, that's why. So simple, yeah. This is a simple. Yeah, it's changed now. That's why I have another file. Simple back. So that's a backup actually. So of course I did the steps, of course. So this is your original file. Yeah, the original file. And this original file, when you convert it, will be converted to the new file up there, and it will make a backup copy. So yeah, so that's something you can do. So if I have a file like this, that looks like this. So I'm copying it here in the terminal. So I copy, copy simple back to simple2 py. Yeah, that looks like this. Now simple2 is just a print hello world. And now when I convert it, and I can specify that I would like to have a backup, and I just say Pasteurize write, and I don't specify the -n, Pasteurize write, simple, and then actually now it provides those fixtures and creates this new file. And now simple2, if you look at simple2, this file looks like this, and there's a backup file that has original content. So this would be the other way, but you see it's not very convenient really. If you want to do it several times, then you always have to rename files as I just did. If you specify output directory, it might be nicer, because you don't modify the original file, you create a new one. There are different strategies, so whatever fits with your workflow, you can do this. You can also go fix by fix. So if you like to, you could also just do some of these fixes. And if you don't specify anything, then you can actually only fix one and actually don't write back anything. It will just show you what it's doing. So I say Pasteurize, and you specify the fix, and you say lib to 3, and you specify which fix you want. Fixes, fix next. So this will also only fix next, and then I specify my toSample file, and then it just fixes this own thing. Yeah, so it doesn't need to be modified. While probably I'm in the wrong directory. Yeah, so I have to check. Yeah, the PySample, I must have fixed it in place. It tells me it doesn't need, nothing needs to be modified, because it's obviously modified already. Yeah. Yeah, there's a modified already. This is a modified file. I must have overwritten this modified file at this place here, but we still have it. Yeah, we still have this original file here, and now I can save this one. Can save this file. Give it a shorter name. So I do have to do it run away. So I have to save this cell 12. Yeah, okay. I have this now saved cell 12 in the new file, and then if I do this same thing with this file, you see that's what happens if you pi2pi looks like this. Yeah, and now I can use Pasteurize, and I use my pi2, and then it tells you what it did, and then yeah, it tells you it has to change only the next. It leaves the other things alone. So you can go fix by fix if you like, and there's many fixes. You can go through all these fixes. That's possible. Or you can fix stage 1, stage 2. Where stage 1 is just all the things to make Python 2.7 more modern. And then stage 2 actually make it Python 3 compatible. Good. Of course, if you do this, you see that it's still important to have tests in place. You should have your source code covered with tests. Otherwise, you might still introduce some problems. Those tools are not perfect. They're pretty good, but not perfect. You have to have current environments. I did it with Conda here, that you can work with Python 2 and Python 3 and test things, of course. You should version control things, that you can redo, undo things later on. And you can go fix by fix or go stage-wise. So these are the strategies you can apply. What fits your needs? You should need to experiment what works for you. If you want to do all files at once or just one file at a time, there are different ways of doing it. Okay, let's do an exercise. So if you go to the PDF, you will find an exercise. So use Pasteurize and convert these files manual and old style step by step. With Pasteurize, so we use a 2 stages approach. You apply stage 1 first and then the next one. Then also apply both stages and check if it works. And if there's any needs, just you need to add it later by hand if there isn't anything missing. Okay, let's have a look at the solutions. So the solutions are very easy. You have to use Pasteurize, and you just need to use these commands. So the Pasteurize command for stage 1 would be -1. Switch Pasteurize command for stage 2 is -2, and Pasteurize for both stages is 0. So if you do this and you just apply it to those files, then it works, and you specify the directory. So if I do this, I just close this here, and I go to the terminal, and I need to go to the directory, and then just copy the files over, and you can apply it. Yeah, so I have my file here, and I just need to Pasteurize I have to go to exercise first, sorry. So in exercises, you have the exercises files, and you can do this directly there. And you might want to create this directory first. So if you try this one, yeah, it created a directory, obviously. So now you can look inside the directory, and you can have your menu. and it creates it. Now it created the output file in stage 1, as you can see here, by applying this command. And you see what it did. Yeah, it changed it. It changed the print. Changed the print here and did the print from future. And now, of course, you can do the same thing for stage 2. For this manual, for the old one, you can also do this. Yeah, stage 2, and you apply it to, and there you go, and then you have your stage 2, and of course you have to say specify stage 1. Then you will take the 1 to move it to stage 2, and then it takes the 1 and moves to stage 2, and will, in addition, yeah, convert your keys to a list, for instance, and does a bunch of other things. Good. You can do the same thing for this old style file, yeah, and then it's converting it to stage 1, and it will tell you what it did. So the print is the main thing, and also it does a next, yeah, and it gets rid of the unequal sign here, and it's also doing the change of the octal number literal. So everything we did by hand before, the tool is doing it for you, and even more because it knows more about it and has more fixes. It has more fixes than we have here, and because there's a lot of small corner case things that you might not think about it, and it will change it for you. So that's the way to go. Use Pasteurize, apply it. It's always good to know what you're doing. That's why it's really helpful to have a basic understanding of the main changes. And there are more than 50 different fixes, so read up on the fixes, what they actually mean. Okay, so we moved our code from Python 2 to Python 3. There's yet another way. You have Python 3 code, and you would like to make this your Python 3 library available in Python 2. We can actually start from Python 3. That's going to work. So I make a new notebook, and we say from starting from Python 3. That's maybe not that common, but not impossible. That's why I show you how to do it. Starting from 3. So we have a very simple file. Very simple file, and this is a simple file we would like to convert. Oh, it's kept me in this solution thing. So we go to the source directory again, and then we have a file which is very, very simple. It is a Py3 sample. Yeah. So actually, that's one I started with. So the Py3 sample looks like this, and this is just a very, very simple file in Python 3. And now I want to show you there's another tool called Pasteurize, and this Pasteurize file is actually doing something with this file. It's converting it in a way that it also runs the same in Python 3. So let's have a look how this works, what you need to do. So I use Pasteurize. First, I go to the terminal. Yeah, I do this as a terminal, and I go up one directory, and I copy my Py3 sample start, because I do it in place, to Py3 sample. Go to right. Good. So, and now I can use the Pasteurize command which is adding all kind of stuff, and I use write, so it writes it directly in there, and I say Pasteurize sample.py, and now it tells you what it's doing. See, it adds a bunch of stuff. It adds a lot of from future import statements. It imports the built-in zip, imports the range, the standard library, and so on. It seems quite a bit, but you don't have to do it yourself. And now when you run the program, it does exactly the same in Python 2 as in Python 3. Yeah, so Pasteurize is adding all the things. Of course, you can do it yourself, but this one will only add the needed changes. Yeah, so it only imports zip if you need it. If you don't need zip, it won't import it. Yeah, and those kind of things. So this one can be useful. Maybe not the common case. The common case is moving from 2 to 3, but here you can also move from 3 to 2 if you need to. This concludes this tutorial. I hope you learned something. So we covered quite a few things here. So we looked at although all these features or many features that changed from 2 to 3 and different ways of doing it. We spent a little bit of time on doing it by hand, which I think is good. You learn something. And we saw there are a few tools out there. Future seems like the best. This is my opinion. And you can apply it, and you still need to know what you're doing. And those tools are pretty good to help you converting your Python 2 to Python 3 code. So I hope you don't have to convert too much, and you will have the luck to work with Python 3 entirely in the future. I hope you learned something in the tutorial, and wish you all the best with your Python endeavors.